Okay, good morning, everyone. We're going to move now to, rather than the new installation, how you actually can make a replacement of a pipe using the same alignment, which sometimes, especially in crowded, the public rights of way under streets, for instance, get quite crowded. If you need to upsize or you need to put in a new line, if you can't replace the pipe on its existing location, then you have to move over and find another spot for it, or you have to rehabilitate. So let's look at first of all, how this technique fits within the kind of chart of different methods. And so we're looking here at replacement, trenchless replacement of a pipe. Pipe bursting is the kind of popular term for it, but maybe trenchless replacement is perhaps a more generic method. And we're dividing it in three different ways, where you replace the pipe within the existing pipe, where you take the existing pipe, break it up, and you push the fragments out into the soil, as Dr. Downey mentioned in the introduction. And some methods where you actually remove the existing pipe. And you have various methods underneath that. So we're not going to talk about this part here where you're talking about slip lining, which is more typically considered a rehabilitation method. But in fact, you can put in a brand new pipe that actually replaces the function of the old pipe. We're going to concentrate in this area here, and where you're displacing the existing pipe. And as Dr. Downey showed you, there are methods where you actually burst the old pipe into fragments, and there's pipe splitting where you have some kind of blade where you slice a ductile pipe. If you try and burst like a polyethylene pipe, the wedge just boom, 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 and it just gets stuck. It deforms the plastic pipe, and you can easily get stuck. So you need a variation in the methods there. And we'll carry on and look at these in a little more detailed. So I'd say we're not going to focus on the within existing pipe, but we're going to talk more about the existing pipe. We're going to talk mostly about this, actually. Existing pipe removed. Pipe reaming is like a directional drilling technique where you have a reaming head with cutting teeth on it. You pull it through the pipe, rotating, and it will actually chew up the old pipe, and then you pull a new pipe in. The pipe eating is based on a microtunneling machine. You actually go down the line of the old pipe. Sometimes, most typically, you might fill the old pipe with a weak grout, for instance, and then you just basically microtunnel out the old pipe, and again pull in a new pipe. And pipe extraction can be used on some pipes where you basically grab a hold of the old pipe and you push it and you pull it and you just slide the old pipe through the ground to get it out. So in all these cases, you wind up with the existing pipe removed. But most typically what you do is to either burst or split the existing pipe. So these are some examples of the existing pipe removed. The pipe reaming, which I mentioned, is based on a HDD type of rig. It drills down. It's set back a little bit so it can drill and make a curve into the manhole. The reaming head is coming along, chewing up the existing pipe, pulling in the new. Pipe eating here is microtunneling based. You can't see very much in the picture. And here's an example of the pipe extraction where you're pulling out the old pipe and at the same time pulling in a new pipe. And probably the simplest way to understand pipe bursting is not the original technique, but it's probably the simplest way to think about it is you have a conical head that is being pulled through an existing brittle pipe. And as you pull that conical slant face in, it creates tensile forces in the pipe. And if it's brittle, the pipe will break into fragments, and that slant face will push the fragments off to the side of the soil. You actually over push them a little bit, so you have a little space in which to pull the new pipe behind it. So they are static and dynamic systems. The initial technique was a pneumatic system, so you basically had that slant face being pulled by a cable and a pneumatic hammer that was actually providing the braking forces. So in that case, the cable pull was mainly to keep the hammer focusing on the old pipe. But then later on, it said, well, if we pull hard enough, we can do the same thing with what we call a static pull. And that can be either applied through a cable system or very often some quick disconnect rod system. And, you know, just a sort of a historical note, if you like, trenchless technology has been a very innovative field. So people see a method, they get the idea, and they try some things. And British Gas developed the original pipe bursting, and they patented it all around the world, and were quite aggressive in collecting their royalty fees on the patents. So there were different people trying to come up with different ways to break the old pipe, and I think partly driven by the idea that maybe this would be a good way, and partly driven by the idea that they wouldn't have to pay the royalty fee to British Gas. So hydraulic expansion was one of those. This was like a device that would nibble away at the pipe. It would actually have rams that would push the cone sideways. And that worked quite well in certain types of soil. But in sandy soil, as I understand it, I think you can imagine that after a while the sand is falling down into those leaves that are being opened and closed, and it doesn't work so well. And this one was called pipe implosion. And there they would actually try and break the pipe inwards so that it would fall into the void within the existing pipe and then push the fragments out. And I think that really was very much an attempt to say, we're not bursting a pipe, we're imploding it. But again, it fell out of use for a while, after a while. So then there are variations where, in where you put the hammer, for instance, in a pneumatic system. The most common is that the hammer, if you're bursting in this direction, you have a nose that goes within the existing pipe. Then here's the expander part, and the hammer is sitting behind. And what that means, gives you a fairly long tool. It's probably the most simple to set up, but you need a large manhole or pit in which to receive this in order to be able to take it out at the other end. So in some cases where you really don't want to have a large reception pit, they have a front expander here, where this is the expanding area. The hammer sits behind it, and when you get to the arrival pit, you can just remove this little bit, and you can pull the hammer back through the pipe and remove it where you started. So there's a lot of little details that, you know, and the techniques to adapt them to different uses. Here's the pipe splitting. I think Deck had actually better photo to show you how it works, but a combination of either cutting wheels here and sail blades. Here again, cutting wheels, sail blade, and slicing either on the sides, or very often they'll cut on the bottom, because then as they push this ductile pipe aside, then it kind of forms an umbrella, if you like, over the where you pull in the new pipe. Here's another picture of the pipe splitting. And you can see in this case the effect here on the old pipe. So when is pipe bursting most applicable? Okay, when when the existing pipe is structurally deteriorated. In other words, you need to put in a substantial structural new pipe. And it's one of the few methods that allow you to rehabilitate a pipe and increase the capacity, because when you pull through, actually, if you over expand, you can go up a size or two with the pipe and actually pull in a larger pipe than you had before. However, you can imagine you're breaking the old pipe and you've got a continuous new pipe. One of the problems you have is, what about if it's a sewer line? What about all those lateral connections that are coming in? And those, most of the time, you have to dig a small pit at each of those locations. So pipe bursting is more effective if you have very few of those lateral locations. So what do you have to do in terms of design considerations? We won't get into them now in this introduction, but you have to see what type of pipe you have to burst, how much upsizing you're going to try. Sizes of the pits are important. In some cases, you can use an existing manhole without any additional excavation. Existing ground conditions and depth. This picture here shows what they found in British Columbia when they did pipe bursting and they got stuck. And what they found, that at some point when this pipe had been put in, they maybe had some ground collapse or something, and they just filled the whole void with concrete. So now they're thinking they're going to burst with soil on the outside of the pipe, and in fact they run into a great mass of concrete that stopped the pipe bursting machine, and they had to dig it up. So you can have quite limited surface impact. This is the cable pulling system going down within an existing manhole. Here you can see this is the guide, if you like, that trains the cable into the existing pipe. And notice here on this side, the manhole is over here, and here's a small pit that allows the existing pipe to bend down on a slant to get down to the level of the pipe. So you can again reduce the amount of excavation. And Dr. Staley mentioned about using pipe ramming for rescue. And here are the kind of hammers that are used on in pipe ramming at the bottom. And here they're being applied to the end of a pipe that is a pipe bursting operation. And here the idea is not that the hammering gets all the way to the front of the pipe and helps with the bursting process. But what they think is most of the effect is that it simply vibrates the pipe and reduces friction. There are systems for laterals. There's similar system, much smaller scale and easy for people to carry. So some of the application issues, you've got worry about the pipe getting gouged. Although this was one we did in a test situation and dug it up afterwards to look at it. These are the pipe fragments, and there was a lot of concern early on that particularly with cast iron pipes, you would break these sharp pieces of pipe, they would get in the ground, and as the ground closed around the pipe, you would get point loadings on the pipe. So and just to finish up, you do have to think about the ground movements that you're generating, because especially if you're upsizing, if your pipe is shallow, the new pipe is probably going to move up. If it's deep, perhaps it'll be more concentric. If it's in a trench where this is looser than the surrounding ground, it's going to be mostly confined within the trench. If you're near a rigid foundation, it's going to try to move sideways a little bit. And in fact, so I might skip that one and say, if you have loose ground below the pipe, then actually you might get the pipe trying to move downwards. So in summary, it's a very fast and very cost-effective way in many cases to provide a brand new pipe along the same alignment as the existing pipe. You don't have to worry about reconnecting laterals. You can do upsizing, and the projects get more complicated as the pipe diameter, the upsizing, or difficult ground conditions come into play. So, thank you.